Okay, in relation to the preceding topic, we will move forward. Now, one obvious restriction that is imposed on the technology is that it is impossible to produce output without using any input. Now, this is another restriction that output is produced only by the utilization of any given level of inputs. If in any case the value of Z1 and Z2 is equal to 0, then we can say that the firm cannot produce any given level of output. Why? Because he is not utilizing any level of inputs. So therefore, if the function f of 0, 0 is given, that is both Z1 and Z2 are equal to 0, then what happens is that the total output level is also equal to 0. That is, y will be equal to 0. Now, this condition is known as essentiality. There is an essentiality if the production function satisfies this condition, that is f of 0, 0 is equal to 0. Now, more interestingly, if it is impossible to produce output without using a particular input, no matter, now suppose I'll first move to the explanation of that statement, then we will read the statement again. Suppose the value of input for Z1 is 0 and the value of input for Z2 is some number, that is f of 0 and Z2. Again, the level of output that is produced is equal to 0. Over here, this one is not equal to 0, but still the total output that is produced is equal to 0. What happens over here is this is the condition of strict essentiality. Clear? Let me repeat it now again. If it is impossible to produce the output, I'm studying the third statement from the slide. If it is impossible to produce the output without using a particular input, no matter how much of other inputs are used, then there is strict essentiality. For example, if input 1 is labor and labor is essential, then f of 0, Z2 is equal to 0. Now after that, what we get is the marginal product. What is MP, marginal product? Change in the total level of output that is produced as a result of change in one or both of the inputs. Okay, what is marginal product? The output level that changes due to the change in either one or both units of the units of both the inputs. So what is MPI? The MPI of input I, that is, there are I number of inputs. There are not only 2 inputs, there are many more inputs as well. Or I can be 2 as well. The marginal product MPI of input I in the production of Y is the rate at which the maximum feasible output of Y changes in response to an increase in ZI, with the other inputs held constant. Now, it is therefore the partial derivative of fz with respect to zi. Why is it partial derivative? Because we know that when a variable depends on more than one independent variable, then when we derive that dependent variable with respect to each of the independent variable, we take the partial derivatives. So therefore, MPI is currently Fi, partial derivative of the function z1 z2 with respect to zi. That is, अगर यहाँ पे z1 z2 है, पहले उसको एक वेरिएबल के रेफरेंस से स्टडी करेंगे, फिर दूसरे वेरिएबल के रेफरेंस से स्टडी करेंगे. Now we do not restrict the marginal product to be positive, like we studied in the function before, where y is equal to f z1 z2. We said that y should also be positive, z1 should also be positive, and z2 should also be positive. But when it comes to the case of marginal product, then there is no restriction that MP should be positive. It can be positive, it can be 0, it can be negative. For this, I will just move towards this law of diminishing returns as well. When we studied the marginal product, in this case, it was equal to 0, it was greater than 0, it was also less than 0 at a particular point. So therefore, marginal product can acquire any value. There is a simple example: if more fertilizers are applied to a given amount of the land, it will eventually reduce the crop. In the start, it will increase the productivity of the crop, then it will become constant, and then the productivity will be reduced. So therefore, MP becomes positive, 0 or negative at a given point of time. We do, however, make the plausible productivity assumption that there is always one input with a positive Marshall product. Now, this is an important assumption. If we say that MP can be negative as well, but in that case, we should have one input whose Marshall product should be positive. ऐसा नहीं होना चाहिए कि Z1, Z2 दोनों की वजह से दोनों की वैल्यू जो है वो इस तरह होगी कि MP जो है that is okay, ऐसा नहीं हो सकता कि curly F upon curly Z1 जो है वो भी नेगेटिव हो और curly F upon curly Z2 जो है that is also negative. No, one of them can be positive, and this is our assumption that one of them should be greater than 0. Now we do, however, make the plausible productivity assumption that there is always one input with positive marginal productivity. Thus, in the previous example, if the Marshall product of fertilizer is negative output, it can be increased by using the same amount of fertilizer on a bigger area of land. Now, that is, its value can be increased by the same amount of fertilizer, and it has to be utilized or used on the bigger area of the land. Okay, now let me stop it over here. If there are any questions.